In the previous video, we learned how to solve simple linear equations. Now this time, we will be just adding a twist wherein some of the terms includes fractions. For our first example, we have 1/3 x minus 8 equals 6. And actually, the process will be the same on how to solve simple linear equations. We set aside all of the constant terms on the right side, and then we retain the term with the variable on the left side in order for us to solve for the missing variable. The only difference is that we'll be adding some extra step, necessary step, in order for us to remove the fractions. So how do we do that? Let's take a look at this example. So here, first, our goal is to remove the -8 here. So let's add 8 on both sides so that this will be cancelled, and that's equal to 0 already. So we're left with 1/3 x as equal to 6 plus 18. Now simplify. 1/3 x is equal to 6 plus 18, that's 14. Now, in order for us to simply remove or cancel our fraction coefficient here in our variable x, instead of dividing it by 1/3, we can also interpret that by multiplying it by the reciprocal. Again, dividing it by 1/3 is also the same as multiplying it by its reciprocal, which is 3/1. So that when we multiply this together, they will cancel out one another. And we're left with x is equal to 14 times 3. And 14 is also the same as 14/1. So we'll just have over 1 in the denominator. And 14 times 3 is 42. 42/1, or simply 42. So the value of our x here is 42. That's it. So here you encountered how to remove or how to cancel our fraction in the coefficient. Now our second example is quite different since we have multiple fractions inside our equation, but don't worry, the process will still be the same. It's just that we will be adding some necessary step in order to get rid of this fraction. So how to do that? First, I want you to look at your equation and make sure all of your fractions are written in either improper or proper fraction. We need to convert this also into improper. So we'll have 5/2y plus 3 1/2 will become 2 times 3 is 6, and 6 plus 1 is 7. So it will become 7/2 is equal to 2/3y plus 5. And the reason I ask you to do that is for us to easily get rid of the fraction by multiplying everything, LCM of our denominators. And the denominators here are 2, 2, 3, and we have an imaginary one here for the 5. So we can simply disregard that. But among the 3 existing denominators, the LCM is 6. So we need to multiply it by 6. So that, if we do that, let's show it here. 5/2y times 6 plus 7/2 times 6 is equal to 2/3 y times also 6 plus 5 times 6. What will happen is we can easily cancel the denominator and we're left with 3 here. Now 3 times 5 is 15. Now we'll have 15y for the first term. For the second term, we also can cancel the 6 and the 2. And we're left with 3 here in 6, and 3 times 7 is 21. So we'll have 21 left. And now for the next term, 6 and 3 have something in common. So this will become 2, and 2, multiply it to the other numerator. 2 times 2 is 4. So we'll have 4y left here. And lastly, 5 times 6, that is simply 30. Now you see, you end up with a simple linear equation which we did already last time. Okay, now doing the process, let's remove the 21. So add a negative 21, so we can cancel this, and we'll have 15y is equal to 4y, and Positive 30 minus 21, that's positive 9. Now for the next step, let's remove the 4y here. 15y minus 4y. Let's write it here on the space here. That's 11y. And this will be cancelled. We're left with 9. So lastly, we divide it by 11. So y must be equal to 9 over 11 so that our equation will become true. And for our last example, you might encounter this multiple times, so better know how to deal with this one. And actually, it's the same idea with what we did earlier on how did we remove the denominators among the terms. So let's multiply once again our whole equation by the LCM of our 3 and 5, which are the denominators, and the LCM of these two is 15. So that we can cancel this. Okay, we can cancel this 3 and 15, and we'll have 5 left in 15. So we need to multiply now 5 by a plus 2. And then the other one is 3a plus 2 over 5 multiplied by 15. We can cancel again the 15 and the 5, and 15 will be left with 3. And we'll have 3 times 3a plus 2. Now to continue, if you can remember the distributive property, which we need whenever we see a term multiplied or a term written together with a grouping symbol, it means multiplication. So 5 times a is 5a, 5 times 2 is positive 10. And then 3 times 3a is 9a. 3 times positive 2 is, this is 9, let's make it different. 3 times 2 is positive 6. Now next is, let's remove the 10 here. And we'll have 5a is equal to 9a. And positive 6 plus negative 10 is negative 4. And let's remove the 9a here. Let's remove the 9a. So this will be cancelled, and we'll have negative 4a here because 5 plus negative 9 is negative 4. And then negative 4a equals negative 4. Now lastly, let's divide both sides by negative 4. So we can also get rid of the negative sign. Okay? And we will be left with a is equal to positive 1. And that makes our equation correct if a is equal to positive 1. Now for your challenge, don't forget to try this and comment your answer in our comment section. And if ever you have any topic that you would like me to discuss, feel free to comment it in our comment section. Thank you.